Let's go.
Next, we are going to move straight on to our next discussion, which is about artificial intelligence, fact versus fiction. This is a discussion to cut through the hype on what AI is and what it is not, and how it is being applied in AEC and CRE today, and what the future holds. Our moderator is the CTO of Shadow Ventures, where he works with Shadow's portfolio of startups on technology challenges they face as they scale. A software engineer by background, he brings a wide variety of experience in AEC, so please welcome our moderator, Matt Ohlman, and our fabulous group of panelists.
All right. All right. Thanks everybody for being here. Super excited to talk about AI, which I think is a quite misunderstood topic in a lot of ways, especially in the startup community. So I want to start out just by asking our great panelists here to just introduce themselves, and I'd like to have them also give a kind of overview of what their company specifically is doing, in AI today. So let's start there.
My name is Latko Bogevsky. I'm the CEO of BetterBot.ai. We are an AI company specializing in with conversational leasing technology. More specifically, we deal with natural language processing and sentiment analysis. And we build bots that help companies handle mundane transactions that are very repetitive and not very well suited for humans.
I'm Lee Thomas. I am the CEO of a company called Project Cost Solutions. We are technically cost engineers. We don't build anything. We work with a lot of owners and architects and engineers to provide how much it costs to actually build a structure on the front end before they actually engage the general contracting community. And so we do a lot of conceptual estimates, a lot of concept, all the way through construction documents. And so right now what we're focused in on for our company in terms of tech AI is really on data acquisition, how that information comes into us and how we can get some of the low-hanging fruit and focus really more on the high-risk areas of providing owners information about costs from an independent standpoint. That's what we do.
And I'm John Powers, CEO of Extensible Energy. We do smart energy management software for commercial buildings. And by smart, I mean aware of what each building is actually paying for electricity, aware of what its own capabilities for generation might be, and its own capabilities for load flexibility. So the energy management space kind of sits at the intersection of prop tech and energy tech. I'm happy to be here because I speak energy as my native language, but I'm learning to speak prop tech here. And the AI application is really all around processing the data streams coming in on the conditions from the grid and the conditions in the building itself. It's more what I would characterize as machine learning than decision-making artificial intelligence, but we can get into that as we go.
I'm Trevor Sanders. I'm on the algorithm team at a company called Avere, and we're automating construction progress monitoring and quality control using laser scans and BIM models. And I guess the AI comes from getting information out of our laser scans. Also sort of more of a computational geometry, computer vision, machine learning application than what I would call AI, but I guess I have strong opinions on that too, so get into it.
Awesome. So you're so great. So I'm just going to start out, give a little bit of kind of overview here and set the stage. So artificial intelligence, which we hear about a lot these days, has been around for a long time. So 1956 was the first academic paper published that used the term artificial intelligence, and that was by John McCarthy. He defined it as the science and engineering of making intelligent machines. In 1950, 6 years before that, Alan Turing, which hopefully everyone is familiar with, there's been a few movies lately and quite well known. So he wrote his paper about the Turing test. The Turing test, while it has some controversy around the effectiveness of it and whatnot, it is kind of the standard even still today how we judge what an intelligent machine is. But the fact of the matter is it's been 69 years since Alan Turing published that paper, and we've not had one machine to actually pass the Turing test. 69 years. So I guess let's start there. Let's kind of bring it back to today. We've been talking about it for 69 years, and it seems like every pitch deck that I get now at Shadow has the term AI in it. It's like you can't send a pitch deck without saying AI. So why is that? What's happened in the last 5-10 years that has really kind of brought that to the forefront technically as well as in kind of the business sense? Zlatko, you can start.
Sure. Well, I felt that the topic is really appropriate because there is a lot of hype surrounding AI. And it all comes down to expectations. And unfortunately, expectations these days are set by science fiction. So when people think about AI, they really think about humanoid machines, they have empathy, make decisions, when the fact is completely different. The fact is that AI is nothing more than very sophisticated mathematical algorithms coupled with large amounts of data processed by very, very fast computers and CPUs. So the technology that we have today in no way leads us to an endpoint where we end up with a machine passing a Turing test. So that does not exist, and we're going to keep working as humanity on improving AI, but as of right now, we don't have that.
So do you think we'll get to that in our lifetime? In the next 100 years, will we have a machine that can pass the Turing test? Because so Turing said his prediction was that in the year 2000 we would have one, a computer. I think it was like with 100 meg of memory. So do you think we'll get there?
I think not, because I don't see anything on the horizon right now that would take us in that direction. Because all the AI right now still comes down to mathematical algorithms, which can just process more data. We're going to end up with faster processors, but we really don't have any way for machines to learn. That's one of the biggest things, that can a machine learn like a human? And the answer is no. We're nowhere near that.
Nice. Anyone else?
I disagree, because why not? I'm kind of a Ray Kurzweil guy, and I think that we don't know enough about how humans learn either, and the case can be made for intelligence and learning being an emergent property, that as the complexity of machines reaches that of the complexity of the human brain, you will see something more like at least a general purpose device that's able to pass the Turing test, and that's probably not on Kurzweil time, but certainly less than 100 years away.
Yeah,
More than my lifetime, unless.
not mine though. Yeah, I think if we see it in the next 100 years, it'll be something emergent that's going to be probably a combination of hardware and maybe wetware, and it's going to result, from a collaboration of neuroscientists and engineers. But again, yeah, next 5 years, probably not.
Well, just one thing I can say from the startup perspective, because we just finished our investor deck and we're getting feedback. And first thing they said was, we had AI on the cover. Take that off the cover. It's basically expected into whatever you're working on. So that was, a piece of advice I can give to startups. If you have that on your cover for your investor deck, you can take that off.
Did that advice happen to come from KP?
No, it's not.
That
KP.
sounds like something he would say.
Yeah.
All right.
At this stage, I completely agree with that. There's the startups we're all running are about a line of business, not about something that is emergent technology in 10 to 100 years. You're trying to get paid now, and you're using computational algorithms as a key tool in doing that. But in doing what? Start with what you're doing. Start with why.
So that's an interesting point. John, do you think that, yeah, like, can especially in prop tech and AEC, can AI be a product in itself versus just a feature, solving other business problems that we already have, or can we actually build like a new kind of platform that's completely AI driven in the space?
Yeah, so I wouldn't call it a product, and I wouldn't just call it a feature either. It's an important tool in accomplishing a goal within your platform and business model. So we're using it to make our algorithms smarter than those that are currently used in energy management. And we've talked in this audience about there being a low bar. There's pretty low bar in energy, there's a pretty low bar in prop tech. It's an astonishingly low bar at the intersection of those two, where I go into a building and see the dusty IT closet with a little XP box sitting in the dust behind a bunch of spare chairs that's running the Johnson Medicine system that's supposedly running the building. I think we can do a lot better than that. And so we're using machine learning and eventually more general AI to do a much better job of managing loads in buildings than the current technology. But we don't go in leading by saying we're an AI company, we're an energy management company that knows how to use data and knows how to use algorithms to do it better than the incumbents.
Nice. So Trevor, you mentioned collaboration, and that's kind of how we'll really advance the field. So let's talk about like open source for a few minutes. So obviously, Google especially has had a big push with open source. How has that helped you in your job, on the algorithms team, to kind of advance your technology and kind of what's the future of open source and AI?
For us, it's been hugely helpful with prototyping things very quickly, and that I think is sort of the point, to launch a lot of startups really quickly and sort of see, where the imagination of the engineers can take us, rather than focusing on building, writing a lot of boilerplate code and trying to get off the ground that way. So, I mean, we've been able to sort of test a pretty significant breadth of algorithms to the end of building our product.
That's awesome. So from an oversight perspective, there's a lot of talk, people like Elon Musk warning of, the future of AI. There was recently someone who suggested that all kind of really hard AI research should be made open source. Thoughts on that from our panelists, especially Zlatko and Trevor?
Yeah. I agree with that. AI, it's just a technique to make something a lot more efficient than it used to be. So if you take, for example, a killing machine, you can make it a lot more efficient by using AI. So that's why I think that we should have some oversight, and I agree with that. I agree with Elon Musk on that. But how we do the oversight too, we need to think about that very much, not to stifle creativity and innovation as well, because sometimes that's the downside of oversight or aggressive oversight.
Right. John, I'm interested, from your perspective on that.
Yeah, I think so. I think that the flip side of that is proprietary AI is just a black box, and it will be much harder to sell. It will be much harder to have that approach trusted by any customer than something that can be reviewed, replicated. So yeah, I think that some kind of non-disguised transparency in what we actually mean by AI is very important.
Awesome. So other than the obvious Terminator situation, which I think we've all kind of decided that's not going to happen anytime soon, what's the other negative? What other negatives are there in AI? What should we be worried about? Trevor?
I mean, I think we've heard a lot about bias being built into algorithms, and that really comes from the data. I mean, an algorithm isn't inherently biased one way or the other, but if we don't have training data that's representative or even favored towards our minority cases, then you're developing bias that way, and that's can be very dangerous.
So talk about the importance of training data. Actually, I'm glad you brought that up.
Yeah, I think it's without data, you're sort of, I mean, probably a failure to launch situation if you don't have a plan for accumulating data, or if there isn't a data repository already out there. At Avere, we spent a long time at the beginning of the company hand labeling some data just to get ourselves sort of off the ground. And yeah, AI without data really isn't anything.
Nice. So Lee, what's next for specifically for AEC and PropTech? What's next with AI?
You know, two things here. The question that you just talked about a second ago in terms of, you know, AI and some of the stuff that we have to look at is the moral implications of AI and decisions that it makes. And so, you know, I was watching this special, they were talking about right now we have the technology where AI can make decisions for, you know, in cars and vehicles. And you think about the decision that it's going to make in terms of protecting me, the person that's in the car, versus, and it's going to make the best decision, which may be a worse outcome for this person over here. And so the moral implications of that, how do we deal with that from a society standpoint of, you're sitting in, when we talk about how litigious we are, how does that work, when the decision that AI made was the best decision for me? So it's interesting, these conversations that we're having around AI and what it's going to look like when my children have their children, and some of the decisions that AI is making, for us as people, as humans, for that. But in terms of the AEC community, in terms of AI and what we're doing, even for our challenge, right now, just the matter of can we get standardized into a process or a set of systems that we all are communicating from the same sheet of music. And so even the data that we're trying to do, working with you guys at Shadow Ventures and other programmers that we have, it's a huge challenge. And the question becomes, how long is that going to take us to get to a certain place where, it's about standardization. So part of my background is Six Sigma. And so, in order to get a consistent process, 99% of the time we need standardization. And so trying to get the industry as a whole to kind of come together and say, okay, well, what's the standard for CAD and, BIM and Rivet and all these other technologies? How do we get there? So.
Right, and I think that really goes back to the data question too, right? I know some of the struggles that you guys are going through, trying to analyze construction drawings with AI. It's like we have to load a ton of data, to train that algorithm appropriately, and that's not something. There are tools now, like Amazon has a ton of training data, but they don't have construction drawings as training data. So I think there's a real gap there, and that's something when I see startups come through and they're like, oh yeah, we're gonna use AI and machine learning to analyze this data. It's like, what data? You don't have any data. You're a startup. You have no customers. Like, where is your data coming from, right? So you can't just sprinkle it on and expect it to work. So I think that's a really interesting point. So we've got a couple minutes left. Did you want to?
I wanted to add one more thing. We're all looking for good use cases, and we have to be careful to find the right use cases. So right now, there are two use cases where AI is really good. One is where you don't have to deliver perfect results. So if you rely on AI for 100% perfection, that's a wrong use case scenario. So that's why some of the best AI right now is recommendation engines like for Spotify and Netflix, because it doesn't have to be perfect. The second thing is find scenarios where the rules are fixed. So for example, why AlphaGo is good, because the Go board is fixed and the rules on how you play Go are always fixed. So look for scenarios that are either fixed or you're not looking for 100% perfection.
That's awesome. And I think that's a good lead-in to, I want to get your take on advice. So if you're in the audience and you're thinking you have a startup and you want to add AI into your product, or you want to make an AI startup from scratch, or you're a corporation and you're looking to innovate and want to add some AI aspects, you guys have been through it. What's the one thing you would give as a takeaway as advice to those people?
I guess for me, it's sort of the machine learning 101 advice, which is to not marry yourself to a particular algorithm right off the bat. Not say I'm going to solve this problem with a neural network, because I love neural networks, but to encourage your engineering team to time box, spend a little bit of time tempting a lot of different solutions to a problem, and then seeing what works the best.
Agree completely with that, and I would add, make sure you do have the good source of data that you're going to need to train it lined up when you get started. We're super lucky to have minute-by-minute usage data and temperature data and grid condition data from the buildings we're working in. That's a very rich source that I'm super excited about and can make a real difference in terms of sustainability in buildings. So try to match what your vision and purpose is with both the algorithm and the available data.
Yeah, I would say just have realistic expectations of what you're trying to do, because even for us to start with KP and those guys and just having the discussion, reality comes in very quickly about what you can do and what you can't do, and the amount of data that you're going to need to actually run some experiments to be able to get the right algorithm for what you're trying to build. So just have some realistic expectations of how long it's going to take to get there.
Anything to add?
I agree with all of you guys, essentially everything you're saying. And look for problems. You don't have to solve 100% of a problem with AI. It's worth it to solve 90% of a problem, 80% of a problem. Look for low-hanging fruit. That's okay. There's plenty of it out there. So, and good luck. Play with it. Have fun.
Awesome. Well, we've got a couple minutes left. Any questions from the audience? Yeah, go ahead.
Yeah, so this is for BetterBot. You mentioned that you were working with NLP engines to do sentiment analysis. I'm just curious if you could comment on how effective that's been.
It has not been very effective. We've actually reduced the usage of NLP, but we found that in certain scenarios it is effective. But in certain scenarios, human-designed social engineering approach was actually a lot more effective. So we've actually stepped back, and the more time we spent, the more we learned about the complexities of this approach. But it definitely solves a huge problem. The product overall has been successful, even though we've had to scale back some of the NLP usage. Great question, by the way.
Anything else? Yeah.
Curious, I touched a little bit on some of the use cases, but curious some of the other use cases in project cost solutions or extensible energy that you guys are using.
Yeah, we're not doing the project costing. We're doing the energy optimization in the operation of buildings, and the use cases around. So this is one of those cases where AI is replacing a job that isn't being done. The facility manager has this list of 100 things he's supposed to do, and deal with energy issues is down around 80. And once he's done calling the guy to fix the elevator and shoveling the snow off the porch and maybe unclogging the toilets, he's done with his day. So the ability to have a cloud-based algorithm watching every zone in the building, watching the whole building meter, watching the output of the solar if there's solar on the building, and optimizing how the building performs minute by minute over the course of the day is something that's just not there. There's no humans doing that. That dusty box in the basement isn't doing that. So that's our use case, and that's what we're laser focused on.
Yeah, for me it's a little bit different. My challenge was when you're talking about putting together a cost estimate for a client, let's say Atlanta Airport is one of our customers, and you have these guys that have 30, 40 years experience in doing this, and we have an aging workforce. The question becomes, how do I capture that knowledge in some kind of way that makes it a lot easier, because I'm never going to get the new engineers fast enough trained to know what these guys know for the last 30, 40 years. And so that's what we started at, to really try to build a solution that says, hey, how can we use machine learning or AI to capture, first to acquire the data, get it in, and how can we get the low-hanging fruit to kind of give us a starting point for the new guys, so that the older guys could then train on what are really the high-risk areas for a cost estimate, that basically you are dealing with a concept about how to put a hotel on top of an existing airport. And then run a train tunnel through it at the same time. And it's a $1 billion project. So how do you take that 30, 40-year knowledge and capture it? And so that's what we're jumping in at, trying to solve that.
Anything else? All right, so we're at time. It's hard to shove a century of AI research and knowledge into a 30-minute talk, and there's obviously a lot of different facets of it. But thank you all for your time. Thanks to the panelists for a great conversation.